Hey guys, welcome back to your second lesson here. This lesson will be for Wednesday, April 8th. This will be your Wednesday lesson. I hope last lesson went okay. I'm kind of recording these back to back, so hopefully if there's any problems, you guys have already reached out to me. And we've taken care of those. I did look over that quiz that I said last lesson was in between there. I'm going to skip that quiz for now. There will be one quiz in a couple of lessons here, but we're going to skip that quiz that was for the last couple lessons. So we're just going to move forward. Today we're going to be in lesson 5.3. We're going to go through here in the next few lessons. We're going to cover areas of these different things: areas of a triangle, areas of parallelogram, areas of a rectangle, area of a squirrel. And we're going to squirrel. Listen to me. Or area of a square. We're going to go through here and we're going to cover some of these different areas and the theorems that deal with those. So we're going to kind of have the same rundown as we did before. I'm not going to walk through the proof, but I'm going to set these up for you in basically formula format so that you can see exactly what it is that they're talking about. And then we'll be able to identify them as they come along on the quiz or tests or so forth. Okay, so take your books. We're on page number 238 today. Lesson 5.3, area of a parallelogram. I hope all of you turned in your homework for the last lesson. I hope it wasn't too hard. It seemed okay as I was going through it, so it didn't seem too complicated. But as I said, if you have any questions, go ahead and reach out to me, and we can deal with those as they come along. Okay, page 238, we're at area of a parallelogram. Okay, we're just going to start at the top there. Any side of a parallelogram may be considered its base. We've already talked about that basically the base of a parallelogram is whichever side that it's laying on. Okay, so as we look at parallelograms, basically we call the base any whichever side that the parallelogram is laying on. And we can take that parallelogram and turn it, and then the base changes with it. Okay, and we turn it, and then the base changes with it. So basically, the base is always whichever side it's laying on. Okay, now when speaking of the base and altitude of a parallelogram, a base and the corresponding altitude are always meant. Likewise for the base and the altitude of a triangle. Okay, so let's look at this first theorem, theorem number 69. Okay, theorem number 69 states the area of a parallelogram is equal to the product of its base and its altitude. Okay, the product of its base and its altitude. Similar to what we covered before for the area of a rectangle. Same thought. Okay, we have theorem 69. We're dealing with parallelograms. So this is basically A equals BH. Excuse me. Yeah, A equals BH. Now, we did talk before in the last lesson that the area of a parallelogram is actually going to be denoted by, let's see, PL. Okay. So what we're going to do is we're going to turn this A that we were using, and we're going to turn this into PL. So remember that PL is always referring to parallelogram. Okay, so because we're dealing with parallelograms, theorem 69 would basically be put as PL equals the base times the height. Okay, again, we're not going to walk through all these proofs. Honestly, I don't have even room on my whiteboard to fit them all in there. So we're just basically going to lay them out in formula form so that when we come to the quiz and tests and things, we'll have the formulas all set up for us. Okay, so theorem 69, again, we're dealing with areas of a parallelogram here. Okay, and the theorems and corollaries that go along with that. So we have our theorem our formula for area of a parallelogram being PL equals B times H. Okay, look at corollary 69-1. Any two parallelograms are to each other as the products of their bases and their altitudes. Okay, so going back here, we've got corollary 69-1. Okay, and this is dealing with two parallelograms. So when we have two parallelograms, we're basically looking at the ratios. Okay, one is to the other as this is to this, okay? So for corollary 69-1, any two parallelograms are to each other as the products of their bases and their altitudes. So we would call this PL to PL as the base and height is to the base and height, okay? So there's the layout there. In other words, we have two parallelograms that we're comparing, okay, and the two together, then our basically ratios, so to speak, okay? So that's corollary 69-1, okay? I hope that we're writing all of these formulas down for this so that we can keep them in our notes. These will come up on our quiz, okay? Basically what I'll tell you is this is for corollary whatever, and then you'll be able to use that setup to solve the problem, okay? So that's how that quiz will work. All right, but let's look at corollary 69-2. Now 69-2 has two parts to it, okay? The first part, A, says two parallelograms having equal bases are to each other as their altitudes, okay? So the B part of that is two parallelograms having equal altitudes are to each other as their bases, okay? So basically we can look at either just their altitudes or their bases, and we can compare them like that. So we have corollary 69-2, okay? And then we're going to have A, okay? And A is going to be parallelogram to parallelogram is equal to, let's see, the first one was altitude. So we've got A to A, okay? And then we have the B part of that, okay? And instead of altitudes, we're looking at bases. So parallelogram to parallelogram is equal to base to base, okay? So that is the two parts of those. So when I'm comparing the two parallelograms, I can look at either their altitudes or their bases. Okay, so that's corollary 69-2. And then we have corollary 69-3. Corollary 69-3. Okay, let me turn my notes around here. Okay. Just noticed I didn't put the thing there. Okay, two parallelograms having equal bases and equal altitudes are equal. Okay, equal bases and equal altitudes. Let me just check something real quick here because I did not put it in my notes and I apologize. We're on 69-3, correct? Okay, so 69-3. Okay, so two parallelograms having equal bases and equal altitudes are equal. Okay, so basically if I can prove that their bases are equal and their altitudes are equal, then I will know that the two are equal. So corollary 69-3. What we're looking for is if base is equal to base and altitude is equal to altitude, then parallelogram is equal to parallelogram. Okay, and that is how that works there. All right, so that was corollaries for 69. Okay, if you'll notice in your book, we're just going to kind of morph right into lesson 5.4, which is the area of a triangle. Okay, these two lessons kind of are going hand in hand, and then we'll pass out some homework and be done with this lesson. This goes a lot faster when I don't have to ask you guys a bunch of questions, and you all just kind of stare at me like, what? So hopefully we'll get through this a little smooth here. Lesson 5.4, area of a triangle. Area of a triangle. So we're on page 239, lesson 5.4, area of a triangle. So lesson 5.3 is area of a parallelogram. Those are all of the formulas that deal with the different types of parallelograms and then comparing the two and what needs to be there in order for them to be equal. In 5.4, we're going to do the same thing, only looking at triangles. Okay, so theorem number 70 states the area of a triangle, the area of a triangle is equal to 1/2 the product of its base and its altitude. Now, hopefully these formulas are not new to you. This is stuff that we learned back in pre-algebra. So we should know these particular formulas, but we're starting off with the basic formula there. So let's go to our whiteboard here and start off with theorem number 70. So theorem 70, our formula is basically 1/2, so T equals 1/2 the base times the height. Okay, 1/2 the base times the height. Okay, so that's our formula for, again, we're dealing here in 5.4 with the area of a triangle. All right, so now what happens when we have two triangles? So let's look at corollary 70-1. Any two triangles are to each other as the products of their bases and their altitudes. Okay, so we have corollary 70-1. All right, now we're dealing with two triangles here. So we've got basically ratios. So T to T is equal to base times the height to the base times the height. All right, so that's how that works there. You've got your product of the bases, and that's how we can determine, that's how we can compare the two different triangles together. Look at corollary 70-2. Okay, corollary 70-2. Again, this one has two breakdowns. So we've got two triangles having equal bases are to each other as their altitudes. Okay, and then just like before, two triangles having equal altitudes are to each other as their bases. All right, so how do we put this down then? We're going to put this as, I'll get it, A, okay, A being T to T is equal to H, which is the altitude, to H, okay? And then B being T to T is equal to B to B. All right, so those are our two options there when we're talking about equal triangles, okay? If they have equal bases, and then they are to each other as their altitudes or equal altitudes to their bases. All right, corollary 70-3, two triangles. Let me make sure I'm on track here. Two triangles having equal bases and equal altitudes are equal. Okay, so this is when we have two triangles. How do we know that they are equal to each other? Okay, corollary 70-3. Okay, corollary 70-3 is going to be broken down like this. T equals T if B is equal to B and H is equal to H. Okay, so if I'm trying to prove the two triangles equal, okay, and I know that their bases and their heights are equal, then I can automatically call them equal together. Okay, so that is comparing triangles, area of a triangle. There's one more here we're going to cover. Turn the page here to page number 240. At the top of the page, corollary 70-4. Okay, corollary 70-4 states a triangle is equal to 1/2 a parallelogram having the same base and altitude. Okay, yeah, a triangle is equal to 1/2 a parallelogram having the same base and the same altitude. So if they have the same base and the same altitude, that triangle is equal to half of the parallelogram. Okay, there's really no formula for that. I guess we can say corollary 70-4. Okay, our triangle is equal to 1/2 parallelogram having, so it has the same base and height. Okay, so that is how that works. Okay, so the triangle is basically half of a parallelogram, and it has the same base and the same altitude. All right. All right, so those are our corollaries and theorems dealing with area of a triangle. Okay, let me look over the homework real quick here and determine which ones we're going to do. But I know we're going to do number 1. So go ahead and find number 1, and we're going to do that one. And then also, let's see here. Let's do, let's do number 1, 2. Let me mark these so I don't forget them. Hope we have all that written down there. But let's do numbers 1. Excuse me, get my pencil out. Number 1, number 2. That's just finding the areas there. Oh, I'm on the wrong one. That won't help us at all, will it? Let's see. Exercise. Where am I? I apologize, guys. I should have had this all marked out here. Got a little distracted. Exercises 4.4. Okay. Here we go. All right, so let's do number 1, number 2, and let's do number 5. And also, how about number 8? Okay, so 1, 2, 5, and 8 will be your homework for lesson 5.4. Okay, lesson 5.4, and that will, 5.4. So that's your homework. That'll be due by the end of the day. Make sure you get it in to me via email or text. Either is fine, and keep on top of that work there. All right, guys, if you have any questions, reach out to me, let me know, and we'll see what we can do to help you. All right, guys, have a good day, and we'll see you later.